Hello ladies and gentlemen, Mr. Eicher here. Welcome to Math 3. This is the Chapter Q practice test number 2, and this video will cover parts or questions number 1 through 6. So let's begin. Number 1. Find the axis of symmetry, y-intercept, and vertex of this quadratic function. A very helpful formula that you should remember is to find the x-coordinate of the vertex. We use x equals negative b over 2a, where the a is the coefficient right there with the x squared, and the b value is the coefficient with the x right there. So we would have x equals negative b, negative 2, over 2 times a, 2 times a quarter. This would be negative 2 over 1/2. And that would be negative 2 times 2. So negative 2 divided by half is negative 4. To find the y-coordinate of the vertex, we'd plug negative 4 into the function f of negative 4. And we would get 1/4 negative 4 squared plus, that's it squared, plus 2 times negative 4 minus 1. Let's see, 16, 4 minus 8 is negative, I think that's negative 5, if I did all that math right. So this is 16, a quarter of 16 is a 4, minus 8 minus 1, so 4 minus 8 minus 1. Yeah, I think that's negative 5. Okay. So our vertex, coordinates of our vertex would be negative 4, comma, negative 5. Conveniently, the axis of symmetry equation is just x equals, it's a vertical line, x equals negative 4. So that means we have a parabola over here, right about here, negative 4 comma negative 5, and the axis of symmetry cuts that parabola into two equal halves. And then the y-intercept, to find the y-intercept, we just do f of 0 into our function, put zeros in here. Putting zeros in basically is going to multiply everything out, and hopefully you could tell right here, the y-intercept is negative 1. So the y-intercept we would have is 0 comma negative 1 is the y-intercept. And I think we've answered that entire question. And we didn't have to graph. So let's see the next one. Find the vertex of the parabola by using vertex form. Vertex form is y equals a x minus h squared plus k. This vertex form is helpful because you can quickly tell what the vertex is, h comma k. Here it's not written in that form, so we're going to have to complete the square. See if I could fit this all on one screen. So we'd have y equals, we're going to factor a 3 out of the first two terms, and we'll leave ourselves a little space, plus blank. And the 35 is kind of in the way, so I'll just put it over here. So again, basically what we did, we took a 3 out of both of these terms. Okay, now we have to figure out what number should we add here to make x squared minus 6x plus blank a perfect square, and that would be a 9. You can get that by doing b over 2 squared, which would be negative 6 over 2 squared, which is 3 squared, which is 9. But be very careful because you have to remember to add 9 to the other side of the equation. Fit that in there like that. So we have y plus 9 on the left equals 3. Now we can factor, plus 35, we could factor this x squared minus 6x plus 9 to be x minus 3 times x minus 3 which we'll write as x minus 3 squared. Oh, we got a lot of stuff going on. Let's change it to green now. Green pen, y equals, we have 3 x minus 3 squared plus 35. We're subtracting the 9, this 9 right there. Subtract that 9 to both sides, minus 9. So we get y equals 3 x minus 3 squared plus, oh boy, mental math, 26. Huh? Sounds pretty good. So, if I did everything right, our vertex, by the way, this is now in vertex form, which is that up there. So our vertex would be positive 3 comma 26. And it looks like that one's all done. Let's look at the next one. Find the equation of the parabola with a vertex given and a point. So we have a point here. We have the vertex at 2 comma 4. 2 comma 4. So that would seem to imply that if this is the vertex and you have to pass through that point, the parabola must be looking like that. There's a couple ways that you could do this. You could kind of try to count, kind of work backwards. We've seen those before. But rather than doing that way, here's a little more formulaic way. You start with vertex form, y equals a, x minus h squared plus k. We're going to plug in the vertex. This vertex here is going to go for h and k. And then this point right here is going to go for x and y. And then we'll solve for a. So let's see, y is 0. We don't know what a is. X is 0. Minus h is 2 squared, don't forget that squared, plus k is 4. So we have 0 equals 2 squared, so that would be 4a plus 4. And subtract 4 from both sides, and it looks like a is negative 1. So our equation then would be, for this parabola right there, y equals negative 1. You don't really need to write the 1, but I'll write it anyway. X minus h, that's h, 2 squared, plus k, and that's k, 4. And there's our answer. Nice job. I think that one's all done. Let's look at the next one. Oh, might need a calculator on this one. Manufacturer has daily production costs of this much. Okay. Where C is the total cost, C for cost, that makes sense, in dollars. X is the number of units produced. How many units should be produced each day to maximize, or each day to yield a minimum cost? Okay. So if we check out this parabola here, the leading coefficient's positive with the x squared term. So that means our parabola is going to be opening up. So that means right here is the minimum. And we'd like to know the minimum cost. So if we use our handy-dandy formula for the vertex, negative b over 2a, that would give us the x-coordinate right here in the axis of symmetry 2. Excuse me. So let's see, this is the b here, that's b, and this is the a. So we have negative b over 2 times a. That would be 100 over 0.10. It sounds like it's going to be 1,000. How many units should be produced each day to yield a minimum? So actually, the answer is 1,000 units should be produced. So that means, again, on our parabola, whatever the parabola looks like, this 1,000 units would give us a minimum value. If you were asked what is that minimum value, you'd have to plug 1,000 into the function c of 1,000 and see what that is. But we weren't asked for that, so we'll just move on. moving on to number 5. For each graph, tell whether the discriminant, now the discriminant is this thing. In the quadratic formula, you might remember the b squared minus 4 times a times c. That's the discriminant. Technically, it's just the part under the radical, not the radical itself. So if the discriminant is positive, so for instance, here's like if it's a negative discriminant, it would be like that. If it's a positive discriminant, it would look like that. And if the discriminant is 0, it would look like that. When the discriminant is 0, we get exactly one solution. And this looks like it would have exactly one solution right there where it's touching the axis. So this one, the discriminant would be 0. When we have a discriminant that's negative like this, we get no real number answers. We get 2 complex number answers with the imaginary unit I. And what that looks like is you never touch the x-axis. So 2 complex would be a negative. Right here, this graph doesn't touch the axis at all. It would have a negative discriminant. And then a positive discriminant, you get 2 real number. They could be rational or irrational. 2 real number solutions, so that means you cross the axis at 2 places. So this would be a positive discriminant, this would be a negative, and this would be a 0 discriminant. Let's look at the next one. Similar to the previous question, we're asked to find the value of the discriminant of this equation. So again, the discriminant is this formula, b squared minus 4ac, and then we'll identify what types of solutions those are. So we have the a is 2, the b is 4, and the c is 3. So we would have b squared, 4 squared, minus 4 times a times c. A is 2, c is 3. So we get 16 minus, that looks like 8 times 3 is 24. So the discriminant is negative. This is equivalent to having something like this. This would give us an imaginary number solution, like that. And when you get that, that means you don't get real roots, real solutions. You get imaginary or complex. So we would say there are 2 solutions, 2 complex roots. If you wanted to see what those roots were, just to verify for yourself, you'd have negative 4 plus or minus I root 8 over 2 times a, which is 2 times 2 is 4. And hopefully right here you could see this right here is the important part. See the plus and minus? That justifies that there are 2 solutions, and the I root 8 is that they're complex roots. Of course, if we were solving, we should make this 2I root 2 if we were simplifying this guy right here. But we weren't asked to do that, so we'll move on. But stuff would divide out, by the way. But we weren't asked that, so we better move on. Actually, we won't move on, because that's the end of the first video covering numbers 1 through 6 and this practice test number 2. Thanks for watching.